Hello students, welcome back. Previously in section 1, we studied integration by substitution, which is essentially the reverse chain rule. Now let's study integration by parts, and that's essentially the reversed product rule. Let's begin with a product rule like this. Let's see. That's the integration by part formula, but that begins from the product rule. So derivative of u times v is u prime v plus uv prime. And then from here, take the antiderivative. So if you take the antiderivative of the left-hand side, you just get uv. The right-hand side is, of course, the antiderivative of this u prime v plus uv prime. And that antiderivative can be separated because we can always separate the integral when you have addition. And then if you flip one of the integral to the other side, that's what you get. That's the integration by part formula. Integral of u prime v, the right-hand side, is uv minus integral of u prime v, the left-hand side. Now some people put v prime dx together as dv and u prime dx together as du. If you prefer this way, that's fine. Either way, it works out. Before applying any of those, please remember this rule. A hierarchy rule. Log of x has strongest tendency to become u, and exponential function has strongest tendency to become v prime, or dv. Oh, dv, no problem here. D already means the derivative. And the power function comes in the middle. As a matter of fact, the higher the k, the more you go to the right. And exponential function has essentially infinite power, and log function has infinitesimally small power. Okay, let's study some example problem. And all right, here we go. Let's use the first convention. From the hierarchy table, u is x, v prime is negative of, no, e to the negative x. So taking the derivative, u prime is 1, and v is exponential stay the same. But then again, by chain rule, you have to do this, 1 over negative 1. Or that. You see, you already have to do an antiderivative already once here. Okay, you're ready. Put everything into this integration by parts formula. Oops. Sorry, a typo. So u is x, and this is v prime, so v is this. So u times v is x times negative e to the negative x minus integral of u prime is 1, so 1 time v is negative e to the negative x and dx. Okay, we're almost there. This one is all set already. Negative x e to the negative x. And then we have negative and another negative, so it becomes positive. And then, okay, if it is positive, what is it? Integral of e to the negative x dx. Okay, we have much simpler integral than before. And let's complete it like this. Negative x e to the negative x power, and then antiderivative of exponential. There you go. How did I get this negative sign? It came from 1 over negative 1. You see, we need 1 over a, right? And it can be simplified like this. Let's do it one more time. This time, let's do it this way. Okay, here's the integration by part formula. And then, let's see. We have x squared and log of x. According to the hierarchy table, log function has higher tendency to become u. So, u is log of x, and v prime is a power function. Then, u prime is a derivative of log, so 1 over x, or x to the negative first power. And v is 1/3 x to the third power. So you see, you already do one antiderivative computation here to there. Okay, all right. Let's put everything into this integration by part formula. U is log of x and v prime is x squared. So we have x squared log of x. Okay. U times v, u is log and v is 1/3 x cubed. So log of x, 1/3 x cubed. And then u prime is x to the negative first power. And then v is 1/3 x to the third power. How do you simplify all this? This one is all set. 1/3 x cubed log of x, and then minus integral of 1/3 x squared dx. Did I simplify correctly? Negative first power, third power, so we have second power. And the resulting integral is much simpler than before. What's the antiderivative here? 1/3 was there before. I have to add 1 to the power, and I need another 1/3. So eventually I get 1/9. That completes the problem. So what do you think? Compared with substitution, it's easier. Yes, you have to do 2 antiderivative problems from v prime to v. Yes, I admit that, but otherwise, pretty much straightforward. And overall, it's going to be easier than substitution. Enough time for one more? Okay, all right. Here's the integration by part formula. And you have to make a decision. What's u and what's v? What do you think? First power, fourth power. Smaller power is u. Larger power is going to be v. Yeah, I didn't specify that here, but exponential is larger power, much larger than any polynomial power, infinite power basically. And log is smaller than anything. It's infinitesimally small. Still positive, but infinitesimally small. Use the same idea. U is smaller power, 2x plus 1. V prime is 3x minus 1 to the fourth power. And then what's the derivative? U prime. The derivative of 2x plus 1 is 2. And the antiderivative of v prime, okay, that can be a little bit tricky. Antiderivative of this, you have add 1 to the power, and then divide by the power. But then again, by the chain rule, I have to multiply by 3 as well down here, so 15. And that's going to be the antiderivative computation. Please check. From here to there. In general, integration by parts is easier than integration by substitution. But the only drawback is v prime to v requires another antidifferentiation that can be a little bit tricky. Okay, are we ready to plug everything into this integration by part formula? U prime v is there. What is u times v? That's u, that's v, so that is 2x plus 1, and then that's 3x minus 1 to the 5th power over 15. Okay, all right, and u prime v. U prime is 2. And then v is this. Let's see. Can you simplify and calculate the integral? Well, this part is all set, so let's simplify this one first. 1/15, 2x plus 1, oops, sorry about that, 2x plus 1, and 3x minus 1 to the 5th power. Now, integral of number part is 2/15, sorry, 3x minus 1 to the 5th power dx. Okay, how do you do this? This one is already all set. Antiderivative of this, well, that was there before. 3x minus 1 to the 6th power now. You have to add 1 to the power. And then you have to divide by 6. But then again, by chain rule, you have to multiply by 3 as well. So 3 times 6 is 18. I can stop here, but let's just go one more step. Copy and paste everything and simplify just one more time. 2 times 2/18, so it's 9. So this is 9. And 9 times 15 is 135. Yeah, okay, 135. Looks like that's the end of the problem. Numbers are so outrageously large that I'm not really certain about this. Let me check. Oh boy. Okay, all good. They differ by constant. I mean, this difference is not 0, but differ by constant. That means the constant will be absorbed by c. So this computation is correct. Well, final problem is left to the students. We just went through integration by parts.